Alright, here's the ideas on trig graphs, the way that pre-calc and ultimately calculus people want to think about sine and cosine function, or need to be able to think about it. We're going to go from the unit circle to these function graph things. So on the unit circle, we're going to let the unit circle fade into the background here a little bit. On the unit circle, the y value is the sine of theta. That's here. And the x value is the cosine of theta. That's right here. And theta is going on from 0 to 2 pi. So theta starts at 0, 1, 2, 3, pi, 4, 5, 6, 2 pi. What we're doing when we do the great wave graphs is we're letting that theta out of it. It's not going to be an angle anymore. It's going to go from 0 to 2 pi, and we're going to follow what sine does. But the input, instead of being theta, the input's just going to be x. So for the sine, y equals sine of x. Now the input is going from 0 to 2 pi, but it's not just an angle anymore. It's not an angle anymore. It's just on the x-axis, going out to 1, 2, 3, pi, 4, 5, 6, 2 pi, just as x coordinates, as inputs into a function now. And what happens, of course, with the sine as it goes around is it works its way up to 1, back down to 0 at pi, and then it goes through its negative quadrants and comes back up to 1. So you just see this going up to 1, back down to 0 at pi, down to -1, back up to 0 at 2 pi, and then it's going to continue. That's the nice thing about, that's the new thing about trig graphs, is they're periodic, because if you go past 2 pi, you just start over, and you do the same thing again. Right, so it's very much done as just, if you copied and pasted this thing in both directions, it would just continue like that and fit together smoothly. So you got a complete cycle of the thing. And for the cosine graph, a little harder to think through, because what was x up here is now becoming the y value of this. The input is still going from 0 to 2 pi, but you're going to see the cosine value start at 1, go down to -1, and come back up to 1. So it starts at 1 on the output, goes down to -1 and back up to 1, and that's what a cosine graph would look like. Between 1 and -1 on the y-axis again. Both of these are. Cosine graph looks like that, and if you copy and paste that thing, it's going to repeat that same shape within each interval. It's 2 pi units wide. It's going to repeat that same thing. So periodic function means this repeats itself. If it has a particular point here at A, it's going to hit that point on the way up, but it's going to hit that point again on the way down, corresponding point over here at 2 pi plus A, and so on. It's going to repeat itself in every slice that's 2 pi units wide. So if we can get a good sense on the graph of what one complete cycle looks like, then the rest of it is just copies of that. So we kind of concentrate on what's going on there. Features of those things, this is basic stuff. Features of those things, we call it the amplitude. How high it gets above or below that is called the amplitude. That's this measurement. And for the basic graph, it's equal to 1. Period is the length of this one complete cycle. So the measuring stick across here is called the period, and for the base graphs, both of these, it's 2 pi. Now the amplitude, the peak value of these things happens at a different point on here, but it's still 1 unit amplitude and 2 pi units for the period. That's the same for both of these things. And then you have the x values that are key here are the beginning and end of cycle. They're 2 pi units apart, but the beginning and end of cycle is from 0 to 2 pi on here. So for both of these, they begin at x equals 0 and end at x equals 2 pi. And end, I don't mean it's the beginning or ending of the graph. I just mean it's beginning and ending of one cycle, so it repeats after that. Okay, those are the key features to that thing. The short version of this would just say that your function transformations apply. Every other wave graph is just some kind of transformation of one of these. But there's a little more to it than that, right? Doing the right transformation and applying it correctly is a big deal here. We're going to look at how all kinds of wave-shaped things can be written as versions of, transformed versions of either sine or cosine functions. And I say either because you might notice that this graph, if I just push it over a little bit, it's really doing the same thing here. This starts and ends here, and if I started here and ended here, it's exactly the same as this graph, just moved over. So really one of these is just a transformation of the other. We just made the observation that cosine of x plus pi over 2 is sine of x, because that would be a horizontal shift, pi over 2 units to the left. No, I'm sorry. Sine, I'm sorry, I got that wrong. Sine of x plus pi over 2 would just shift this graph over to the left by pi over 2, and it would be the same as the cosine of x. So this one of these is just a transformation of the other, in fact, but that's not that useful. Other wave graphs are transformations of these. We want to start with one or the other as the base graph and move it around, and I want to make some notes about what impact that has on the graph and on these basic measurements out here. That's what I want to go through in the second part of this video.